All right, so you should all see it now. And we went over the syllabus, we went over the webpage. Feel free to email me with questions anytime, because as I said, I'm really fast with email. Usually I'll respond within 24 hours. If I don't respond within 24 hours, send me the email again, because probably something went wrong, because I usually respond pretty quickly. I do, take a lot of the material. A lot of them is from Scott Clemmer, from other HCI textbooks. We're going to do a bunch of Don Norman today. So I just like to cite where I got a lot of the materials from. Now, human-computer interaction, or you'll hear me say HCI for short, it's interdisciplinary. And what's so cool about it is you have, it's computer science, but it's not only computer science. We have psychology and other fields as well. And I've had students from psychology working with me and students from computer science. And many times it's computer science with psychology minors, because they're interested in HCI. And it does have a lot of human and people aspect to the field. And I'm going to read this only because I love this quote, and you'll see, like, in the beginning of the semester, I do a lot of Don Norman, and particularly I like the book Design of Everyday Things. And even though it was written a while back in like 1988, I find that it's very useful and applicable even today. And now I'm going to read it. So, you would need an engineering degree from MIT to work this, someone once told me, shaking his head in puzzlement over his brand new digital watch. Well, I have an engineering degree from MIT. Give me a few hours and I can figure out the watch. But why should it take hours? I have talked with many people who can't use all the features of their washing machine or cameras, who can't figure out how to work a sewing machine or a video cassette recorder, who habitually turn on the wrong stove burner. So here, what this is saying, which happens to all of us, is like, think about, like your camera. Think about, even on my phone, my camera, I don't know like all the features that I can use. It's complicated. And there's so many things that you're like, I wish I had an MIT, an engineering degree from MIT, then I could figure it out. And it's like, but is that, true? And what if you had that degree? Would that make it any easier? And I find this with a lot of things that I'm like, I don't even know how to work this. And if I don't know how to work this and I'm a computer science professor, that's pretty embarrassing that I can't do this. And you might feel like that as students in computer science. And it's like, people are asking you, and it's like, so why are things so complicated? So people have asked, and I want you to think about it. How can we improve? And I actually brought it. This is my show and tell, except, oh no, can you see it? My measuring cup. How can we improve the measuring cup? So, think about it. What would you say if someone said, how can you improve this measuring cup? So if you ask people, they were like, well, maybe the handle got hot, or maybe it sometimes can be slippery. But observing people, if you ask people things, it's okay, but it's not going to be as good as observing. And what they found when they observed people using the measuring cup is, think about how you would use it. This is a standard, like, I don't know. I know some of you like to cook probably, right? And so you've probably, most of you, or a lot of you have probably used a measuring cup. And if you think about it, you're like pouring something in it, then you're looking like, I need 1 cup of, 1 cup of water. And you're looking, did I get it to 1 cup? And you're looking, and they realized people had this like stuttering, like they were stutter measuring. They would pour a little look, did I get it? And it's like, well, that's not a great way to measure. And this is such a standard measuring cup that, how many of you have a measuring cup that looks like this? It's like, I know you can't see it well, but it's a pretty standard measuring cup. And they're like, but people are always like, is this good? Is this good? I have a little video, and you'll see me in my kitchen trying to using it, and you'll see that that little stutter measuring. It's on my webpage. And so then they made better measuring cups. They said, well, there's different measuring cups. You can have an improved one. I actually bought one of these too, which we'll see if you can't see it. You probably see it better on my shared screen than in front of me. It's the first one that's there. Yeah, you can't see it so well, but I bought one of those. And what's nice about these measuring cups is that you can actually pour from the top and see the number. So as you're pouring in, you want 1 cup, you don't have to look to the side and say, did that work? And because it's showing you on top. Oh, I need 1/3 of a cup. Okay, I just got it. So they actually have improved measuring cups that don't do that. And so that's something that they only realized because they observed people, and observing was different than actually asking people. Sometimes people think they know how to improve something or what would improve it if they're asked, but when you watch them, they don't even realize what they're doing. So how many of you have ever pulled a door that was meant to be pushed, or pushed a door that was meant to be pulled? I know. You have, good, because I've done that. Okay, but now I'm going to ask you a more embarrassing one. How many of you have ever walked into a glass door? Like just walked into it face first. That's happened too. And so this also is a quote from Don Norman, but I shouldn't have trouble with doors and switches, water faucets and stoves. I push doors that are meant to be pulled and pull doors that should be pushed, and walk into doors that should be slid. The answer should be given by the design without any needs for words or symbols, certainly without any need for trial and error. So now this is from his book, and you can see a door where you're not sure which side to push from on top. And then on the bottom, you can see one that's obvious, which is a better design because it's obvious which side you need to push. And I'm going to show you my example. Actually, oh no, where is it? Here it is. I'll go back to that video after. This is my example, because how many of you recognize where this is from? I was walking, through the buildings, and all of a sudden I'm like, what? And I was like, I pushed this one to open this door, and I was like, what is going on? I'm just walking through, and it's like, if you're walking one way, it makes sense. But so, and doors, there shouldn't need to be, it should be so intuitive that you don't need to read, like, wait, okay, let me read this, and then say, push this side to open this, push this to open this. It should be, this is a door. I just want to walk through the door. I don't want to have to like read something. It should be, and good design is so intuitive that you don't even realize that it's a good design. It's when it's a bad design and you have to stop and think about it, that then you realize this wasn't a good design. So our next one is stoves. Now this is less of an issue now, is more of an issue. When I was a kid, I had this like horrible stove. It looked like the first one. You see that, the arbitrary picture? It was totally arbitrary. And what was worse was that since it was so old, the words were rubbed off. And so you had no idea like what would do what. And I remember like when I was younger and I would like turn on one, then turn on another, like I was like a guessing game to try to get which was the right stove. And they're much better now. Like they're not as arbitrary. I mean, these are pictures of better ones where it's lined up. I have a screenshot. I'll show you an image of my own here. You could, and don't complain that it's really, really dirty, because I haven't, it is really, really dirty. I know that. But this is, I just, went to my kitchen and took a photo, and you can see it's much more obvious. Like this is, you can see it's so obvious which knob is for which. And so they do make them much more obvious today. But it used to be like, you have these knobs on the bottom and you're like, you have no idea which one is which, and it's a guessing game. So it's like, there's ways to do things that are better designs, and there's ways to do things that are worse. And that's the trick, thinking about how to make something so it's more intuitive and people don't have to think which burner goes with which. All right, so poor design. So one thing that happens is people tend to blame themselves. They're like, I'm just too stupid to figure this out, or I'm clumsy. That's why I keep mixing. Oh, there's my coffee pot, my funny coffee pot picture that I said we would get to. But most accidents are, they're attributed to human error, like, oh, a person made a mistake, they just couldn't do it. But a lot of times it's not the person's fault, it's the designer's fault. It's like a poor design. And in the course, a lot of times, and especially programmers, they tend, and this is what I'll try to get you in the mindset of not doing, but programmers tend to be like, our stupid users, our idiot users, they're just so stupid they can't figure this out. But in the course, we're going to try to be a little different and say, well, if a lot of users are making that mistake, then it's not the user's fault, but it's the design. And, and as the people learning to be HCI professionals in this course, we're going to learn about how to include users in the process, check what they're doing. So we don't end up being like, oh, those, programmers who are just being like, well, those are our stupid users, but people that we realize the designs should be different. And maybe it was the poor design choice when they did this and not necessarily the user's fault. So when people have trouble with something, and we'll try to talk more about the designer and what the designer could have done, and not just criticize. I mean, I know we just did that now, and we spent 10 minutes criticizing, but then think about the examples you gave, and think about the solutions they could have made. And this is why it's good sometimes to counter it with a good solution. So, like a good product. So yeah, maybe this feature isn't good, but think about a feature that did this well, and think about a solution that they could have done. And and that's something that really could make the designs better, by thinking about what could they have done that would have made this better. So for the designer, assume people will make mistakes, like any error that could happen, assume will happen at some point. And design so as to minimize the chance that these errors will happen, and that if they do happen, the consequences aren't so severe. So, like the errors, like if you don't lose your whole paper on Microsoft Word if you X out without saving, but think about, the warning, are you sure you want to say? So think about, or reversing, or being able to retrieve something that you thought you didn't want. So think about making the consequences not as severe, because people will make mistakes and humans will make errors. And as the designer, just assume that that's going to happen, and do it so that it's not, so that you could minimize the errors. And think about forms that you're filling out. And sometimes they give you those warnings, and we'll learn about designing good forms that just say, that give you those errors, like, phone number needs to be in this format, and, or something that just helps you along the way. Now, we'll also talk about accessibility towards the end of the semester, and how to design for, when we say design for users, we mean all users, and all users are different, and people have, may have different disabilities, and there's different ways to accommodate, so that you're designing for all. And older users, older adults, elderly can be included in this, because a lot of issues that elderly have with design are actually, they might not be able to see as well, they may not be able to hear as well. So a lot of them are really things that, like are things we'll talk about with other disabilities too, that will also help people who are elderly, and elderly count as people with disabilities, because they have a lot of these challenges, and in similar ways, and they won't want things that are too much color or too distracting. So we'll talk, we'll have a couple of weeks during the semester where we talk about, I think 2 or 3, where we talk about really designing accessibly for all. So know your user. When you talk about your user, if I'm making D2L, then who are my users? Like, you guys tell me, who are my users if I was designing a learning management system? So think about all of them, but you might need students, you might need teachers. So you don't want to just say, okay, I got 2 18-year-old students to do this, because okay, that might be good for someone who's 18 years old, but we have students of all different ages. So different ages, different genders, different races, like there's just, users are all different. And then you have beginners, the first time student, like even in my own course, HCI, we tend to get people who are early on in their career, like in their degree, and and then because it's open to anyone. And but then you also can have someone who's almost graduating, and they're taking this, and so they're very comfortable with things. So it's really like, is this a beginner student who hasn't used D2L before, or is this someone who's used this for the past 4 years? So usually HCI professionals are called in too late. Like, you'll design something and you'll be like, oh, there's some issues, let's go call someone in. And it's like, it's already built, it's already designed, and they're like, okay, can you help us? And it's too late. I mean, it's not too late, but it's not done right. The way to do it, and a lot of the companies are doing this now, are better at doing it now, getting HCI professionals from the beginning, bringing them into the process from the beginning before anything is coded. We'll be doing that. You can design on paper, you can design on using prototype software without actually knowing how to code. And this way you can do it, show it to your users, see if they're comfortable with it. Then once everyone's happy, then go and spend all that money coding, but it's going to be done right. So having people who are trained in HCI and who can look at good and bad design and look at what's good, and having them early in the process will be very beneficial than calling them in too late at the end. And then it's like, but we already spent so much money coding this, and the coders will not want to change the entire thing at that point. So I'm not going to read all of this because of time, but you can read it on your own, and it's from the Design of Everyday Things. And I kind of like, it's the end of the book, but it kind of gives us a foundation for the semester and what we see. And how I want you now, one thing I want you to take away at the end of the course will be going places and noticing designs. Like sometimes you just don't notice it or have words for it, but now you'll be like, oh, they did this really well, or, oh, they designed this really poorly. And it's things that you wouldn't have necessarily thought of. But from this course, I'm hoping you'll have a different mindset, where even just this week alone from one class, I think you'll walk around and start noticing better. When you open a door, you'll be like, oh, that was a good door, or that was not a good door. And so just the mindset of looking at designs and seeing what's good and what's bad, and we'll take away and appreciating the designers, or thinking about that was not good, how could we have made it better?